Hi, welcome to the Pole Shift News, the home of the Math Star Observatory. Guys, there are a couple of things I want to get through in this video to do with muons, cosmic rays, and also a recent study done on the magnetic pole migration, where scientists believe it could take, during the process of a reversal, 22,000 years to complete. So we're going to look at that, and we're also going to talk about muons, a little bit more about the nature of muons, why we're going to now start observing muons with these new muon detectors that we're going to be building. By the way, we've reached already halfway of the target of building this project, and I want to thank everyone that has been chipping in to get that budget together so that we can then begin building these muon detectors. So great big thanks to those people and those people that are supporting the observatory and our efforts at this point in time. So guys, looking at this NASA space weather overview, you can see that the implications of this increase in radiation is becoming more and more serious. And they're saying that the cosmic rays will intensify even more in the years ahead as the sun plunges towards what may be the deepest solar minimum in more than a century, guys. So that is just what is being leaked out now from these organisations, and as you can see, that it does lead to cardiac arrhythmias in the general public. So everybody is susceptible at this period of time, especially as we're in the trough of solar cycle 24. But this is a problem which is set to continue. We haven't reached equilibrium yet, and I just want to show you why that is on the next chart. So as you can see, solar cycle 22, 23 and 24, for the last 33 years of these three solar cycles, we have seen an exponential decrease in sunspot numbers. But nevertheless, every time we get into the troughs of these cycles, cosmic radiation increases, as the solar cycles decrease themselves. So we end up having consecutive weakened solar cycles. Then at the end of these troughs, what we're going to see is an increase in cosmic radiation. If I just scan up the page, you'll see exactly what I'm talking about. Let me find the chart that we're looking for. So here on the space environment overview, we've got the sunspots on the top there. You can see solar cycle 24 just beginning, and just before that you can see a massive increase in the cosmic radiation. If we go back to before solar cycle 23, it isn't as much as what is in the end of solar cycle 23, but it is more than what we see in the end of solar cycle 22. So if we just go back down to that first chart we was looking at, we can see that as these sunspot cycles and the numbers of sunspots drop off, we have an increase in cosmic radiation. What I can say, guys, with regards to all this data that we're looking at, is the future is not looking good, and for a lot of reasons. First of all, our primary protector of cosmic radiation is our sun. It creates like a bubble, which is called an heliosphere, around our solar system, and during these low periods of sunspots, or at the troughs of these cycles, we have a shrinkage of the heliosphere and more galactic cosmic radiation is inbound. Adding to this, guys, we also have a weakening magnetosphere, and we're going to get on to just talking about what scientists are now coming out with regards to this 22,000 year period of which it takes for a pole shift to go through. So from when it starts to reverse to the point of where it's reversed, it will take 22,000 years. So let's have a little look at that then. So this is the article from Scientific America, as you can see, and it's titled "The Earth's Magnetic Field Reversal Took 3 Times Longer Than Thought." A new study suggests that the last field reversal, 773,000 years ago, took 22,000 years to occur, which could explain some of the inner workings of our planet's core. It doesn't explain nothing, because to date we have never been able to, despite many attempts to recreate how the Earth generates, first of all, the magnetic field that we have and the poles as a reason of that magnetic field. But guys, I'm going to show you something now which blows this completely away, because if they're saying now that it takes 22,000 years to occur, what we've already recorded over the last 100 years doesn't fit anywhere within 22,000 years. In fact, to my workings out, in the last year, and I'll show you on Google Earth in a minute with our pins and where the magnetic pole is right now, in the last 100 years, the magnetic pole has already migrated 1,774 miles. And if you times that by 7, you get 12,418 miles. And that is half the circumference of the planet. So in 700 years, according to, if the magnetic pole just kept a fixed speed, which it doesn't, it would still go through a reversal arc shorter than 22,000 years. Because according to what we're seeing, it would be 700 years. Let's have a look at the pins on the map on Google Earth, just so we can clarify this. So something's not right here, and I'm not sure why they've put this out. But as you can see, this is from August the 7th, 2019, so it's a recent article that has been carried out by some university and maybe some professor. But let's just see how this doesn't stand up to what we know already about the magnetic pole. So what I've done here is I've just took the measuring tool from when the magnetic pole started to migrate in the 1900s to the present date of where the last pin is, or thereabouts. And as you can see on the measuring tool, we've got 1,779 or thereabouts miles of migration in 100 years. And the other thing is that as time has gone on recently, the poles have migrated faster and covered more distance. In fact, I think this chart debunks their findings instantly. Just logic, as you can see, from the 1900s to 1990, the magnetic pole migrated 500 miles. From 1990 to the current date, it's migrated an extra 1,000 miles. So you add those two together, we're at around about 1,700 miles, as I showed you on the Google Earth with all the pins. And if that's the case, the poles are going faster now than they ever have done. You can see it's not far off moving vertically up the chart. And if that's the case, all you have to do is a simple bit of math, is that in 100 years, we know that the poles have migrated 1,774 miles or thereabouts. If you times that by 7, it tells us that in 700 years, the poles will have completed 12,418 miles, which is half the circumference of the Earth. And if the poles from the north to the south reverse, then they're only going to reverse 12,000 miles or half the circumference of the Earth. It just makes perfect logic sense. So this 22,000 year reversal period is completely unfounded, according to the facts that are clearly out there. I've got to say, guys, I'm really confused and I'm concerned about the confusing messages that are coming from these university professors right now. I'm also concerned because over the several years that I've been studying this anomaly, it is not looking too good, our future, for a number of reasons. If we just set cosmic rays and particles aside and look what happens to a planet when it loses its magnetosphere, I'm talking about Mars, by the way. We know that Mars had water on its surface and had an atmosphere, and it doesn't today. We know that it had a magnetosphere, and it doesn't today. And if we are losing our magnetosphere, guys, what we do not want to see happen to our planet is it end up looking like Mars, because it will sterilise the entire diversity of species on this planet across the range. Do you understand? It will destroy everything. And if we lose the water on our planet, there will be no more life. Our bodies, as you already know, consist of about 95% water, and so does every other cellular life form on this planet. Nothing will live without water, and that is what is at threat if our magnetosphere depletes completely. Even for a prolonged period of time with a weakened magnetosphere, it poses a massive biological threat to all biodiverse species across the range. And we know that these organisations are investing literally billions, first of all, in the study of particle physics, and more interestingly, recently, with Japan or China building that £1 billion facility just to study cosmic rays, guys. Something else is going on here, quite clearly. And it seems to me that when they make their announcements, there is confusion, because one department comes out with something that another department doesn't seem to agree with. You know, they're still stumbling over the fact that they don't know what's creating the magnetic fields in the first place on our planet. Yet, at the same time, our magnetic fields are weakening on this planet. And my concern, as I've mentioned it many times before, is the last completed reversal was 780,000 years ago, and that is 500,000 years more than what it should have took for a reversal to happen. Something's definitely going on in the core of our Earth. If over just 12-month period the amount of active in eruption volcanoes has halved, if in the last 10 years we've experienced the most devastating earthquakes recorded in history, as well as all the other anomalies that are taking place, our climate is shifting, guys, as a result of the magnetic poles reversing, and on top of that, making it even worse for ourselves, a grand solar minimum taking place right now. And there is no signs of any equilibrium. Can you imagine that? We haven't even reached halfway point where things begin to just show some slight signs of improvement. Setting all that aside, you know, guys, it is amazing that we've managed to do this on our own. And I can see this happening a lot more often with other fields of science. I can see people like your good selves supporting small outfits like the Mavstar Observatory in the search for the truth of what's taking place. And we're doing an absolutely fantastic job. We've already had Jeff over in Perth, Australia, offer to house one of the cosmic ray detectors, as well as one of our magnetometers. And, you know, I dare say that will be like the case for some of the other people that have already got our magnetometers. They will also want one of the cosmic ray generators, sorry, not generators, but detectors. And we'll get a global outlook of how much radiation is inbound and how fast it's increasing. The two coincide really nice with each other, guys. And let's face it, we study mainly on our channel and our website and our observatory the magnetic pole reversal and the highs and low intensities now, because we're going to be sending one out to Brazil, one soon out to South Africa, so we can monitor the low region intensities of our planet of magnetism, and in those regions maybe even also get a fix on how much radiation is actually inbound for it via cosmic particles entering our atmosphere and colliding with other particles. I did have you know, a bit of information that I'd written down on muons, because that is what we're going to be detecting. And as you know, muons are a byparticle of a collision that's happened high up in our atmosphere, and they're unstable particles, very high energy, and they have a very, very short life, which means they don't exist after a couple of microseconds. In fact, if they're stationary, they exist even less. So moving particles, usually at the speed of light, they're travelling a lot faster, seem to have, you know, a lot longer lifespans of around about 10 microseconds. And it is only that fact that they're travelling at those speeds that allows a muon to come through our atmosphere to the surface before it decays completely. And that's down to, if you want to look it up, time dilation. Basically, it's probably a function of the fact it's moving at the speed of light. It's deforming time in its own relative state, so it doesn't appear that it's travelling 10 microseconds at the speed of light. To the muon, it's only travelling 2 microseconds, although the lifespan doesn't change, but the fact that it allows it to come through our atmosphere, you know, and to the ground and be measured, is a component of its just speed. If it was stationary, it would already have decayed and disappeared and we wouldn't detect it. I know it's a bit confusing, guys. It's part of special relativity if you want to look up all these things, but the fact that we can measure muons gives us an indication of cosmic ray strikes up in our atmosphere. And if our atmosphere starts to you know, weaken then we're going to have more of these inbound. If our magnetosphere, which protects our planet, weakens, we'll have more of this. And if our sun continues to go down a progressive path of cycle depletion, then we're going to have more cosmic radiation. So I think it's definitely the right step now that we've taken to monitor muons at our observatory and relay that information that we gather globally to you guys. And if you want to support the observatory, there's a link down there. Remember, we're halfway through our budget, getting our budget to complete the build of these 20 cosmic ray detectors. And if you want to support that, the links are there. If you want to support the observatory, the links are there. Guys, this is your observatory and I work for you, and you know, in order to do that, we just need a little bit of support. Remember, if these organisations have got the facility and the funding of billions of pounds, then what we're doing at this level globally is amazing on the amounts that we do raise. Honestly, we're doing a fantastic job. We just need to continue going forward. Okay, the link's down there. We've got a Patreon link, we've got a PayPal link if you want to make a one-off donation. And guys, it's not mandatory, so you don't have to support us, but you know, you already support government institutions that lie to you and don't give you the information. So why not fund something directly by yourselves? At least you get more from it. I hope you see that you do get more from it from us. And you know, I'll just wish you all the best for the rest of the week. Again, I was hoping that we had a delivery today of just the piping now, and we can do a run test on the cloud generator. That allows us to see cosmic radiation live and muons as well, guys. So anyhow, I'll say what I usually do. Enjoy the rest of your day. I'll catch up with you again. As always, bye for now.